Okay, my friends, so we got ourselves a little bit of a spreadsheet here. I was putting it together, and I think it's going to work pretty well for you if you liked that visual of the lines crossing that we saw in class yesterday. So I'm going to kind of walk you through the examples we did in class in the sheet because we already did them by hand. So and then you can decide if you want to use it or not. So the first one we did in class was this warm-up with the tanked versus the tankless water heaters. So I'm going to give this one back to you tomorrow, but here's the data that we had to run. Conventional tanked water heaters, $1,300 to replace. The tankless is $3,500. I'm writing this down on a piece of paper because we're going to go over to the sheet in a second. $450 a year to run versus $300, so it's more expensive per year, but it's cheaper up front and vice versa. Okay, so then the question was how many years of use would have to pass. Okay, so over here, the way the sheet works is, if you want, you can name the lines. I don't know why I put 4 lines in here. Whatever, I'll just leave them there. You can name them. So I'm going to name them. I'm going to call it tanked and tankless. And you can see when you do that over here, it renames them on the sheet. Okay. The variable cost and the fixed cost. This is what we were talking about yesterday. So for the tanked water heater, it's got a more expensive variable cost, but a cheaper fixed cost. And as you enter these numbers in, what you're starting to see over there on that axis, or on these axes over here, is it's starting to graph the line for you. The tankless is cheaper per year, but more expensive up front. Now, right here, it's kind of hard, and this is where step 2 comes in down here, this line. It's hard to see. You can kind of see they're probably crossed right about there, but it's really hard to see because I wanted to build you a sheet that could work for any type of data. Well, this is 1,000 years, so that doesn't make any sense, right? This is way longer. So if you remember in class, now we didn't know what this was going to be, but it was talking about years passing. So 1,000 years is ridiculous. We're all going to be dead multiple times over. So you might adjust it down to 50, and what that'll do is it'll make a quick little adjustment, and now you can actually see where they cross. And if you want to refine it even more, you can knock it down to 20. I'm not real sure why it's doing that little funny little shimmy. You see that little shimmy when you that little, yeah, I don't know what the hell's going on there. But anyway, so you can tell, actually 25 is pretty good. It looks like it's coming in right under 15 years, maybe. And I think that's what we came up with in class, right? We decided it was something like 14 and a half years. And then I put here, if you want, you can add chart and axis titles if you wanted to. As a matter of fact, I'm going to make one more change while we're here. Give me 1 sec. Okay, that's a little easier to look at. Maybe you're color coding your data over here with the lines that are over here. So your tankless, you can see, starts more expensive, and then it just doesn't grow as quickly as the tanked does. And then I color coded line 3 and line 4. I put line 3 and line 4 on the off chance that we end up analyzing more than 2 things at the same time. We'll see. Maybe we can just, if we end up not doing, you can just delete those cells. Okay, next example we did in class was, I think it was the solar panel one, right? Yep, it was this one right here. And we wanted to know if we use 10,000 kilowatt hours of power each year, how long till we start saving money. Okay, so let's go back to the sheet. So we're going to go with panels and without panels. And we're going to try to spell words correctly because, you know, yeah, it's a math class, but it's also, I'm also an adult that should know how to spell things correctly. I'm going to shrink the fonts down. Let's delete line 3 and line 4 out for now because we really don't need it. Okay, so the fixed cost, I'm going to do the fixed cost first here. You know what? One more thing. Okay, feel better about that formatting. Fixed cost. With the panels, there's a fixed cost of $5,000 because we have to install them. Without the panels, we're not going to have to spend anything. Now we have to go in and check we have to fix the variable cost. This is what we worked on in class. Without the panels, we have to spend 11 cents per kilowatt hour, and we used 10,000 kilowatt hours. So what's kind of cool about this is I can just do the math right in the cell. Kind of nice, right? I can do the math right in the cell. It's going to pop up, and there now, that's without the panels. This is not correct because it doesn't cost me $450 a year for power. I forget what we calculated, but I remember it was 75% of the 11 cents per kilowatt hour times the 10,000. So there's the formula I just typed in right there. That's how much we spent. We spent about $825 a year on power, and that agrees with what we got yesterday, right? It was somewhere right around 17 years or 18 years. I forget exactly what we came up with. Somewhere in that neighborhood. Beautiful, beautiful. Okay. The next one I had to think about was what happens if we use more power? 17,000 kilowatt hours instead of 10,000. Okay, so all I can do now is I can go in and just change these numbers to 17,000. And this was a fun one because I remember some of you were like, wait a minute, this doesn't make sense, because the turnaround point now is more like 11 years instead of 18. And we talked about it, and hopefully it makes sense as to why that does make sense indeed, because if you're using more power, even though you're paying more for power every year, you're also saving more every year. Here we're saving almost $500 a year, where before we were only saving about $350. Now, yes, we are paying more out of pocket. Yes, I'm not doubting that. But the panels are going to pay themselves off quicker because we're saving more every year. Okay, so that's the two things you have to get your brain to kind of agree with itself there. Okay, and we did one more. I think it was about the Ford Escape, right? Oh yeah, the Ford Escape. We did the old 2012 Ford Escape. Okay, and I'm going to try to remember what we came up with in class together here. Oh wait, I don't even have to remember. I can just do the math in the spreadsheet. That's what makes this kind of fun. Okay, so this is going to be V6 versus hybrid. Okay, so now we're going to change that. We'll delete these for now. We'll go back to them. Fixed cost for the V6 was the cheap one, $13,322. The hybrid was $19,560. Okay, beautiful, beautiful. Variable costs. Okay, this was the fun one. We had to figure this one out, and it took some dimensional analysis to figure this one out. We had to take the $4 and divide it by 23 miles per gallon, and we rounded this thing off. Whoa, let's knock some of those decimals down, shall we? We called it, I think, 17 cents. I forget what we called it exactly. So 17 cents per mile to drive the V6. Okay, and if you want, you can change these things to match. You can change them to dollar amounts if you want to make them. Actually, I'm not going to do that because in case we're not, we're always going to have dollar amounts though, aren't we? I'll let you decide if you want to change them or not. Okay, anyway, hybrid cost, I think we also used $4 a gallon, but we were getting better mileage, so it's going to cost us less per mile, more like 12 cents a mile. Okay, beautiful. Now, when you look at this graph over here, you're going to take a look at it and be like, wait a damn minute, Sean. Those lines look parallel. And again, this is why I built this down here into here. You've only driven 25 miles according to this chart. Remember, spreadsheets don't know what you're thinking. It has no idea what you're thinking. It knows what you put into it. So if you remember, we had to drive a lot of miles. So if you start inputting larger and larger mile amounts into this graph, it's a little hard to see right there, but those lines are starting to tilt upward. It's a little bit hard to see, but you can see how this distance here is a little further away than this distance here. So as you keep increasing the mileage, the maximum mileage that you're seeing, now you can totally see that they're starting to creep upwards. What's less obvious, probably, is that the blue one is increasing at a higher rate than the red one. A little hard to see, so let's go to 50,000 miles. Yep, and I don't know, it's a weird little shimmy and shake that it's doing there as you adjust, but you're starting to see it. The blue line is going to catch the red line. The question is, where is it going to catch the red line? There's that weird shimmy and shake. Oh, we're almost there. Let's go out to 125,000 and see if that was far enough. And it looks like it is. It looks like it is indeed. So you're going to take this intersection point, which is where the break even is. You're going to drop it down, and you're going to kind of interpolate and interpret that. That looks to be about, I don't know, what would you call that? So these are 25,000 each. So the next one would be also 125. So halfway would be about 112. I'm going to call that like 110,000 miles. If you want to, I bet you there's a way we can get in here and adjust the horizontal axis. I don't feel like dealing with it. You know what? I'm not going to do that. Because if I adjust it for this graph, it might not be good for a different graph, right? Right. So I'm not going to change that. I'm going to leave it exactly as it is. Okay, my friends. So that's how this sheet works. I will get it in Canvas for you. I'm going to reset it back to what it looked like originally, where everything was empty. So that way, if you do your homework, which is a follow-up on those V6 hybrid things, line 1, line 2, line 3, and line 4. Let's fix all the fonts back so they're the same size. Actually, let's just make them all size 10. Yeah, that looks pretty good, right? And this doesn't need to be that large. Sorry, you're watching me edit spreadsheets now while I'm recording the video. I guess I'll hit stop on the video and give this to you so you can actually use it. So when you first open this video and you open the spreadsheet, apologies for the confusion because I made some editing changes while we were doing the video. But you know what? Y'all are pretty damn smart. You'll figure it out. All right, I'll see you tomorrow, friends.